that a zoo sponsored a one-day contest to name a new baby elephant. Zoo visitors deposited entries in a special box between noon t equals 0 and 8 p.m. t equals 8. The number of entries in the box t hours after noon is modeled by a differential function. E for 0 is less than or equal to t, which is less than or equal to 8. Value of ET in hundreds of entries at various times t are shown in the table above as given. For A, it asked, use the data in the table to approximate the rate in hundreds of entries per hour at which entries were being deposited at time t equals 6. Show the computations that led to your answer. So the question asks us to find E prime t, and to do so we would want to take the values of 5 and 7 because 6 is right in between and use that. So what you do is you do E of 7 minus E of 5, then you take the same value, so 7 minus 5, then you plug everything in, you get 21 minus 13 because you have the values in the graph, and then you just simplify that, 8 over 2, which is equal to 4, and then don't forget your units, hundreds of entries per hour. I can't talk today apparently. And that'll be your answer. So all I have to do is just circle that. So point-wise for part A, all there is 1 point offered, and that is for getting the right answer. Otherwise, it's just a very simple setup of finding E prime 6. Just plug in E7 minus E5, 7 minus 5, simplify, you get 400 entries per hour, like we found in the work. For Mr. Calculus, he said exactly the same thing as all work previously shown, as all the students got the answer. Simply set E prime of 6 equal to E7 minus E5 over 7 minus 5 and just simplified it down. The common errors in this problem that you could find are either simple multiplication errors, which I'm gonna be honest are probably really hard to have here because it's just simple subtraction and division, or just forgetting the units. So for students, student A did this flawlessly, set it up perfectly, got the E7 minus E5 over the 7 minus 5, simplified it, got the 400 entities per hour at t equals 6.
So part B said, use a trapezoidal sum with the 4 subintervals given by the table to approximate the value of 1/8 times the integral of ET from 0 to 8, and then using correct units, explain the meaning of this in terms of number of entries. So it said use a trapezoidal sum. So from the data given in the table, we use that to find the area of the trapezoid. So the area of a trapezoid is base 1 plus base 2 divided by 2 times the height. So using the numbers we have here, we have
so here the 4 is one of the bases and the 0 is the other base from these. These are the bases. And the 2 is from the distance. It's from dt. So the 2 would be 2 minus 0. And then the 3 here would be 5 minus 2. And so on for these heights.
So to save time, I just plug this into my calculator. And then so this right here, the areas, is the integral. So we still need to times by 1/8. So that is a common mistake. Most people forget that you still need to multiply this by 1/8. So when you multiply this with 1/8, you get 10.688 is your answer. So for the rubric points, you get 1 point. Doesn't matter. 1 point you get for setting up the trapezoidal method. The second point you get for your answer. And then the third point is to say what the meaning of this is. So this represents the average number of hundreds of entries in the box between noon and 8 p.m. And in Mr. Calculus, they did the same thing as us. They found the area of the different trapezoids using the data from the table. And in their answer, they also had 10.6875, but both answers are correct. So now we look at the sample student responses. So here, they did the same thing as us. They found the integral of this. So, and it looks like they did it all by hand. So you could actually just box this instead of do it all by hand, and that would save you time. So they found their answer, which was the same as us, and then they explained what this meant. And then, so the key concepts of Part B is using the trapezoidal method, knowing the bases and heights, and you get that from the table given.
So Part C says, at 8 p.m., volunteers began to process the entries, and they were processed at a rate modeled by the function p, where p of t equals t cubed minus 32 squared plus 298t minus 976. And this is in hundreds of entries per hour for time 8 through 12. And according to the model, how many entries had not yet been processed by midnight, or t equals 12. So I knew that it was asking how many were left to be processed, and because I knew that there were 23 total from the table that was given to us in the problem, I decided to subtract the total number of entries and then take away the entries that have already been done and processed to give us the ones that were left. So I took the integral of p of t from time 8 to time 12, which is specified in Part C. And so I thought that the quickest way to do this one, because this is a calculator question, is to plug it into my graphing calculator. So I plugged in the function p of t for y1, and then I exited out and I did the integral of p of t with a lower limit of 8 and an upper limit of 12 to find the area under the curve at that point, which is what it would look like on a graph. And then when I hit enter, I saw that the answer was 7. And so that means that at midnight, there were still 700 entries that had yet to be processed. So one of the most common mistakes you could make is thinking that 7 is the rate at which entries are being performed, or how many they'd already done, not what they had left. And it's also really easy to forget to subtract from the 23 and then to get negative 7 and go, oh yeah, but it's negative and you can just make it absolute value and make it 7. I mean, technically that's the right answer, but it's not the right way to do the calculus, so you probably wouldn't get a point for that. And then it's also really easy to plug in e of t, because that's the function that we were given in the original problem, not in Part C. So it's just important to make sure that you use the p of t function and not the e of t that's given in the table. And so for the AP Calc rubric, you get 1 point for setting up this integral properly, and then you get 1 point for the actual answer of 700 entries that are left after midnight. And then Mr. Calculus did the same thing. So he actually said, so he actually plugged in e of 8 minus this integral, but instead of saying e of 8, I just immediately plugged in the 23. So it's really the same thing. Now we were looking at the sample student answers given on the AP Central website. So for problem 2C, we looked at how they found the number of process entries and then how many were left to process after midnight. So they did the same thing we did with this integral of p of t from 8 to 12 to figure out how many had already been processed. And they plugged it all in and showed that it equals 16, and this is like a fine answer if it was just the integral, but if they put the 23 minus in front of this, that could be an okay answer. So then they showed that the number of unprocessed entries is 8, because that's the given lower limit, minus the 16, and then given that e of 8 equals 23, they said 23 minus 16 equals 7. And then they used the correct units and said 700 entries had not yet been processed. And if I were this person, I would have said 700 entries had not yet been processed at t equals 12, because that's just a more specific way to answer the question and show that you understand what they mean by t equals 12. So the key concepts for this were being able to find that integral and recognize what needed to be the upper and lower limits and which function needed to be in the integral, and then plugging that in and actually integrating it. And then also like knowing that you needed to subtract that from the 23 was a really big thing. And the other biggest thing is the initial condition, and knowing that it's not like plus 23, it's like 23 minus the integral.
So Part D says, according to the model from Part C, which is the function p of t, at what time were the entries being processed most quickly? Justify your answer. So finding when it is processed most quickly means finding the rate at which it's being processed. So you have to find p prime of t. So p prime of t is equal to 3t squared minus 60t plus 298. And so when it's processed most quickly, it also means an absolute maximum. So then you would set this equal to 0 to find any critical numbers. So I decided to do this on the calculator instead of by hand. So I plugged the p prime function into my calculator and then I graphed it. And then I noticed that the graph went off of my window, so I decided to extend my x to 15 instead of 10. And then I noticed that there are 2 zeros. And I used the zero function to find that there are zeros at t is equal to 9.183 and 10.816. And so these are the critical numbers. However, since we're finding the absolute maximum, not the relative maximum, we also have to take into account the endpoints, which are 8 and 12. So then you would test both the critical numbers and the endpoints to find which one is the highest. So then you would plug these numbers into your p of t function. So p of 8 is equal to 0, and p of 9.183 is equal to 5.087, and p of 10.816 is equal to 2.911, and p of 12 is equal to 8. So looking at these values, you notice that p of 12 is the highest because it's equal to 8. So then that means at time t is equal to 12, the entries are being processed most quickly. So Mr. Calculus did the same thing. He found p prime of t and he set it to 0 to find the critical numbers, and then he included the endpoints, and he also found that at time t is equal to 12, it was the greatest value. However, he said at time t equal to 12 or midnight for the answer. So both these answers would be acceptable for an FRQ answer. And then for the rivet points, they give you 1 point for setting p prime of t equal to 0, so that's 1 point. And then they also give you 1 point for identifying the candidates, which would be these 4 numbers. So you would have to identify these and plug them into the p function to earn 1 point, so that's another point. And then you would have to find the answer, t is equal to 12, for another point. So in total, there are 3 points for this question.
And then so you probably want to have t equals 12 be your answer, just so you're clear on the number. And then so some common mistakes with this problem are
We'll be leaving off the endpoints, and that would cost you 2 points because the answer is an endpoint. So if you didn't include the endpoints, then you would get 9.183 as an answer, and that would be wrong. Part D, the sample student responses. So this student, they did everything we did. They found p prime of t and set it to 0, and they got the zeros, which were at t, which are the critical numbers. And then they did the second derivative test by finding the p double prime of t, and then they used it to find which was the min and which was the max. And so since 10.816 for p double prime is greater than 0, that means that it's concave up, and that would be a min. So they just went with 9.183, which is concave down, which is a max. So then they only used those 3 numbers, 8, 12, and 9.186, and then they still found that t is equal to 12 was the fastest, and that's what they got for the answer. A key concept for part D would be just finding the absolute maximum of the function.